of this chapter. Okay, so 1.6, evaluating claims and thruster forces. So our closing task, you guys are going to be able to construct a model to explain why the pod didn't dock with the space station. Okay, we're going to be explaining how a force can change an object's motion today. All right, we were going to construct a model. For activity 1, we're going to do our warm-up. We're going to fill in the blank with the correct answer, explaining how the thruster's force acted on the pod if each claim, so claims 1 and 2, is correct. All right, this page will take you straight to that warm-up. I'm going to read the instructions real quick. So ACM pods normally fire the thrusters with a force that stops the pod and allows it to dock at the space station. For this pod, something else happened. It wants you to think about the thruster force in successful missions, then compare that to the thruster force that would cause the situation in each claim. Then complete the claims below the image. So you're going to be given a picture of the claims, what the claims say, and then below that you're going to fill in the blank, talking about the thruster force. Okay, so go ahead, if you have not already, click on this page and it will take you straight to that warm-up. Once you're done with the warm-up, click Hand In and come back to our Pear Deck. All right, take about another minute and a half to do that warm-up. All you're doing is filling in the blank. And once you're done, make sure you're back in our Pear Deck. All right, so in most cases, those pods will move in one direction, and the thrusters will exert a force in the opposite direction. Okay, so we know if a force comes in the opposite direction, it could either slow something down, it could stop it, or it could make it go in the opposite direction. All right, so the right amount of force should make this pod stop moving so that it can dock. That's what we want. That's what we wanted to happen. So in claim 1, the thrusters caused the pod to move in the opposite direction before it even reached the space station. Okay, the thrusters caused the pod to move in the opposite direction before it even reached the space station. So it didn't even touch it, or didn't even touch the space station. In claim 2, the force exerted by the thrusters did not stop the pod, and so instead it kept going until it crashed into the space station, which made the pod move in the opposite direction. So we know that in claim 1, the pod did not touch the space station, but in claim 2, the pod did touch the space station and bounced off of that. All right, so think about this question real quick, and then the next question is going to ask you which claim you think is correct. All right, so what can you infer about the thruster force that would have caused the situation described in claim 1, and what about claim 2? So what can you infer about the thruster force in each of those claims? Was the thruster force too strong? Was it too weak? Was it just right? What do you think? And what do you think could have happened? All right, so this next question is going to ask you which claim you think is correct. So take a minute. Try to decide which claim you want to back up so far. We aren't going to actually pick a claim just yet to support. We are going to go over both claims, and we're going to get some information and explain both of the claims. So we technically aren't picking a claim, but I do want to see which claim that you guys are thinking about right now. All right, so I only have 6 people responding in Pear Deck, so if you are not responding in Pear Deck, please make sure you're in there and answering the question on the screen. Which claim do you think is correct? All right, I need a few more people. Make sure they're responding in that. There is really not a correct or wrong answer here because we don't have enough information just yet, but I want to know what you guys are thinking. All right, I'm going to look at the responses. We're kind of close. My last class, a lot of them had said claim 1. But like I said, there's not a wrong answer here, and you don't have to change your answer just because you see more people choosing 1. So whatever you think right now, which claim do you support? All right, so a lot of you guys are saying claim 2. Now it's getting a little bit more even. All right, the next few classes and the next few lessons, we are going to eventually choose a claim. We are not doing that today, like I said. We're going to go over both claims today and model and write about both claims. So for activity 2, we're going to use the modeling tool. So if you were here on Friday, that should help you out with trying to navigate through this modeling tool. It shouldn't be too tough, but if you were here Friday, it probably helped you out with the modeling tool. If not, we can go over it if you need to. So the first thing that we're going to do for activity 2, we're going to review the email from Universal Space Agency. And then we are going to eventually use that modeling tool to create 2 separate models, modeling claim 1 and then modeling claim 2. So here is our email from Anna Gonzalez from the space station. So I'm going to read it to us. Great work so far on your investigation into what happened when we lost contact with the ACM pod. As our team investigates what kept this pod from docking, your models and arguments will play a key role in helping us understand what could have caused the pod to move away from the space station. Was there a problem with them out of force exerted by the thrusters? Your explanations will help us interpret the data we are trying to recover from the pod. We hope to have some data soon. Keep up the thorough work. Okay, so we are going to be looking at the thruster forces today. So let's look at claim 1 and claim 2. You guys are going to make 2 models, 1 for each claim. Okay, you're making 2 models, 1 for each claim. So we'll send these to the space agency to explain how the thrusters could have affected the pod's motion. In the first model, you guys will show how the thruster force could have caused the pod to reverse direction or to move in the opposite direction, right? That is what you're going to do in the first model. For the second model, you guys will show how the thruster force could have caused the pod to only slow down and then hit the space station. Okay, we do know that it went in the opposite direction because it did bounce off the space station, but the pod only slowed down. All right, so what you guys are going to do is complete your models for claim 1 and claim 2. Do not worry about the annotations to your modeling tool. I thought there was a spot on there that you could do annotations, but I could not find it, so don't worry about doing annotations. We'll be writing about it anyways in our 3rd tab of Amplify. So you're going to complete models for claim 1 and claim 2. So if you want to go ahead and press on the screen, I'm going to share my screen and make sure you guys know exactly where to go to do those models. So if you want to press on the Pear Deck screen, you can, and it will take you to our activity 2. All right, give it a second. It's logging me into Amplify and going to the correct spot. All right, so it will take you to the page that we read the article, or not the article, but the letter to us. And then if you are down at the bottom, if you click on that second and that third circle down there, you will see modeling claim 1 in the second circle, and then you will see modeling claim 2 in the third circle. They look almost the same, but please make sure that you're doing both claims. All right, so when you click on modeling claim 1 in that second circle down there at the bottom, you will see a page come up that looks like, give it a second to load. It'll look like this. I'm going to reset my page so that yours looks exactly like this. All right, this is modeling claim 1. So you have this before force, you have the during force, and you have the after force of what the pod is actually supposed to look like. So you have a medium velocity, you have a medium force acting in the opposite direction, which makes this object stop. Okay, that's what's supposed to happen for the pod to dock. What you're going to show is claim 1 in this case. So you'll drag this object up here, and you're either going to put force in that middle column, whichever one you think is correct, and then you will end up putting the velocity after the force, because we know that the object is moving after the force, but you have to determine which way. Okay, so make sure that you are looking at claims 1 and 2. I will keep them on my Pear Deck so that you can see them and come back to them. But make sure that you're modeling claim 1 and then modeling claim 2. Make sure you're clicking hand in as well. All right, take a few minutes to do that, and we will come back together in about 5 minutes. Okay, so make sure you're on tab 2. There's a wall there. I should get done with the class earlier than normal. Take about 2.5 more minutes to finish up those models. You should be in tab 2 of Amplify. Take about 1 more minute, and then you're going to come back to our Pear Deck. Take about 1 more minute and come back to our Pear Deck. All right. Make sure you get that finished up. I have a question for you here in Pear Deck. So if claim 1 is correct, would the thrusters apply a stronger force or a weaker force? If claim 1 is correct, would the thrusters have applied a stronger or weaker force? Right, so we remember in claim 1, the thrusters caused the pod to move in the opposite direction, and the pod did not hit the space station. So if claim 1 is correct, would the thrusters have applied a stronger or a weaker force? Go ahead, choose your answer. All right, make sure you're finishing up that model and back in our Pear Deck. It looks like I've got 7 people responding, 8. All right, so if claim 1 is correct, would the thrusters have applied a stronger or a weaker force? All right, looks like about half of us are responding. Please respond so that I can show some answers or responses. Okay, make sure we're responding in Pear Deck. Perfect. We got 100% right now. All right, so if claim 1 were correct, the thrusters would have applied a stronger force. That would make it go in the opposite direction. Okay, now think about this claim in claim 2. If that is correct, if claim 2 is correct, if the pod hits the space station and bounces off, did the thrusters apply a stronger or a weaker force? So if claim 2 is correct, would the thrusters have applied a stronger or a weaker force? Go ahead, answer that question. And we will see what everybody else is saying. Thank you to those who are responding in our Pear Deck. All right, so make sure we're answering that question. If claim 2 is correct. Even if we don't think claim 2 is correct, make sure we're responding to that. All right, so we know that claim 2 says that the pod hits the space station and bounces off. Ooh, we're kind of all over the place here. All right, so let's think about this. If claim 1 was correct, all right, if claim 1 was correct and the thrusters caused the pod to move in the opposite direction, we know that there's a stronger force. Okay, there's a stronger force than the velocity. Now, if the pod doesn't stop and it only slows down and then it bounces off the space station, is it going to still have that stronger force? Is it going to have a weaker force? Is it going to have the same force? That's what you need to think about. If the thrusters cause the pod to move in the opposite direction in claim 1, we know that there's a stronger force. But if the pod hits the space station and only slows down and then bounces off of it, is it still going to be a stronger force or is it going to be a weaker force? Okay, for those of you that are still unsure, what are you unsure about? For those of you that are still unsure, what are you unsure about? Y'all can send me a private chat, unmute yourself, whatever you would like, but I want us to make sure that we are all on the same page. All right, so we know that claim 1, the thrusters are going to apply a stronger force, right? We all said that they would apply a stronger force if it goes in the opposite direction. For claim 2, right, we know that the pod is not going to dock. The pod's going to slow down. It's going to hit the space station and it's going to bounce off. All right, so we should be seeing weaker force. We should be saying weaker force. It's not going to be a stronger force because if we have a stronger force, then it's going to go in the opposite direction. It's going to be a weaker force because the pod only slowed down. And then it hit the space station and bounced off. It's not going to have a stronger force. It's going to have a weaker force. All right, for activity 3, we are going to be writing. But before we get to that short piece of writing, we are going to write down our key concept. This is the only key concept you will need. So as soon as you put this down in your digital notebook, you can go ahead and exit out of that digital notebook. All right, so first, for our key concept today, we are talking about cause and effect. So understanding a cause and effect relationship can help you infer what led to a particular result. Understanding a cause and effect relationship can help you infer what led to a particular result. Now I will go ahead and put this in the chat so that you can see it there, and if you're falling behind at all, right, make sure you get that down in chapter 1, lesson 6 on that page under important ideas. Right, so we know that force and velocity have this cause and effect relationship. That's what we've been looking at this whole chapter. So understanding a cause and effect relationship can help you infer what led to a particular result. All right, make sure you get that down in your digital notebook and then exit out once you are done. All right, take about another 15 seconds to get that in, and then make sure you're back on our Pear Deck. Shelby, if you need to write it down on a piece of paper right now, then you can. I was hoping to make sure you guys have your digital notebook pulled up at the very beginning of class, just because of things like this. All right, so if you need to write it down on a piece of paper or write it down on Word, then you can do so. All right, so make sure you get that in. I'm going to go on to the next slide. Okay, Shelby, just write it down, and then you can put it in there, hopefully when it starts to load. All right, I told you guys we were going to write, and we are going to write about the two claims in terms of this whole cause and effect relationship. So Dr. Gonzalez is interested in understanding the relationship between thruster force and the change in the pod's velocity. Okay, so we have been talking about force and velocity. So this will help the team at USA interpret the data. So when you guys are writing about the claims, you will need to clearly state how a stronger or a weaker thruster force could affect the pod's motion. Okay, so you're talking about a stronger or weaker thruster force and how that would affect the pod's motion. All right, you can use some vocab to make your thinking clear, and that will be pulled up here in just a second. So before we get started, we're going to review these examples to help us understand how to explain a cause and effect relationship. So this example asked what caused the jar lid to start moving across the floor. And so if you guys remember, Mr. Livingood had made us a video talking about the investigation, and he actually did the investigation with the jar lid and pulling the spring launcher back and seeing which one would cross or go to the end of the meter stick first. And so right here, you are answering this question, what caused the jar lid to start moving across the floor? And we want to pay attention to the answer for B, all right? The answer for A is really short. It doesn't give us a lot. It just says the launcher caused the lid to start moving across the floor. We want to have an answer like B. So when I released the launcher exerted a force on the jar lid. As a result of the force exerted by the launcher, the velocity of the jar lid changed and it started to move across the floor. All right, so we want to explain the force of the thrusters and the change in velocity like this. All right, I don't want to see any answers like A right here. I want to see more answers like B. You're going to use vocab words and you're going to use some cause and effect words as well. And I will have those up for you. All right, so there are two parts to the writing activity since we have two claims, right? So we will answer both of these. You will see this in Amplify. So as you write, you can use the provided word bank, and the word bank is going to be on your page in Amplify, so you'll be able to just scroll up and see the word bank and the cause and effect words and phrases as well. If you need to use the modeling tool that we just used, you can go back to those as well to help you explain your thinking. Before you guys begin, here are a few questions to consider as you write. All right, so did the thrusters fire too long or did they not fire long enough? Would this cause the thrusters to apply too much force or not enough force to the pod? What effect did the thrusters have on the velocity of the pod? Did the pod touch the space station during the lost time? And explain why the pod is now moving away from the space station. All right, these are just a few questions to think about while you are writing. It is up to you how much you write. Just make sure that you are getting your point across. Okay, so this page, this is what you're going to go to if you want to go ahead and click on it. We're going to be writing about the cause and effect relationships. And so I'm going to read the directions real quick before you get started. If you understand what we're doing and you want to go ahead and go, you can. It says to explain the events that would cause these changes in velocity. For each claim, you're going to describe the thruster force and how that would result in the pod moving away from the space station. So you're given claim 1 and claim 2 right there. What you're going to do is you're going to use the word bank, the cause and effect words and phrases, in your modeling, your 2 modeling tool diagrams if they are helpful. Okay, so go ahead, click on this page. I'm going to give you guys about 6 minutes to do this. So we will come back together here at about 11:53. All right, go ahead, get this done. Make sure that you click hand in when you are finished, and then come back to our Pear Deck.